Hello, yeah, welcome to the lesson 6 on machine learning. So, before we start, we have to we have an objective today. Let us first import these variables. We have to import pandas, we have to import matplot, we have to import sklearn, we have to import sklearn as what model selection, to import train and test. For this lesson, we are bringing out a new term, training and test data. Okay. Now also we are bringing also another new term, linear regression. We have to import linear model as what import the linear regression. We have to from scaling matrix, we have to import mean square error, our square. So let us run it. It has run. We run now. We have written a code. The code is all about the question, the answer of what question of we have a problem that we wanted to solve, provide the format of file. But so it's a question. We have asked a question. Let us run the question. What is the question all about? The question here is that the objective here is we have to predict concrete compressive strain using multiple linear regression. Yes, there is an app that I came out with on concrete compressive strain. So many friends were asking, "Oh, say how manage?" Watch this video right up to the end. Okay, everything is for free. It is more preferable for you to learn something than to go and pay something which obviously all the resources are around you. So this is for prediction of concrete compressive strain using multilinear regression. Are we together? You're going to see everything here. Okay. Now, this is the question. So, given the following data set, where each row represents a mixture of concrete components with their respective quantities and the age of a concrete in days, predict the concrete compressive strain using multilinear regression. Okay, that is the question. Okay, now for us to continue, let us look at now what our data column. What is there in our data column? Let us have written this code for us to visualize what is inside our data column. Okay, so let us visualize it. Now, this is our data column. Now, on the data column, we have a cement component. Okay, it's measured in kilogram per meter cube. We have glazed funnel slack, right? It's measured also in kilogram per meter cube. We have fly ash. These are various materials that when you combine this material, the combination of this material give a good strength in concrete. Okay, so now we are determining that okay, if we are going to use 8 of this material, what will result for the strength in the compressive strength of concrete? You can decide if I need to use but 5, what will be my compressive strength? But now I can decide that if I use 8, will I still have the same compressive strength that you use with 5 of this material? If you combine cement, glaze funnel, this water and superplaster, then you don't put coarse aggregate, would there be an effect on the compressive strength? This is where the question lies. Okay, now let us see on how to solve the problem. If really there is something lacking, we are going to know on how to solve it. If we are going to use but 8 of this material, but you need to understand that if we need to combine all this material, that we need to bring the cement, give number of cement, the volume of cement, everything, then we will need to batch. We are going to spend a lot in the site. We are going to spend a lot in the company. But now the machine now learning now bring us now what with a summary that we can run this without any expenditure. But now you are going to know that okay, if I use this batch, this is how the compressive strength will be. At that point now, when you are going out in the field as a field worker, you are going out to understand that if I use this exactly batch and this, I'm going to realize this compressive strength. So it is not as if you have to test. You carry out various tests, carry out various tests of material until you realize the compressive strength. So all those old method has gone. So we are learning now. We are using now machine learning, artificial intelligence, to order to solve all those problems. Expenditure have to go. So we now need to come out now in the preface that okay, when we use machine learning, this problem is solved. So watch to the end, you see how we are going to solve this problem. Yes, now what is the task? What is our task? Now let's run this program for us to know our task. Now our task now, what we are going to do is that we have to prepare the data for the training by splitting it into the training and the test set. Okay. The second, we have to implement the multiple linear regression model using the suitable machine learning library. So we are going to use with Scikit-learn. This is machine learning library. This is a machine learning library Scikit-learn that we are going to use. Then now we say train the model on the train set. Are we there? Fourth, we have to evaluate the model performance on the test set using the appropriate metrics. Okay, we have what arrow square, we have mean square error. In our previous lesson, we have done at least on gradient descent for you to understand the concept about this mean square error. Are we there? If you haven't watched our previous lesson, please I will advise you to go back and watch them. It will be more very important for you. Then now you report the coefficient of the regression model to understand the influence of each component on the concrete compressive strength. Okay, so in the next is we have to what? Load our data, load the data. So the F, we call the F PD the rate SF, we have to copy and paste what? The part. So this part of this data belongs to what? Where I name machine learning on concrete compressive strength. So when we load the data, we then now we can call the data TF, right? This is our data. Are you seeing? We have cement, we have glaze funnel, these are the various material for concrete. Are we together? Yeah. Yeah, but looking at this our data, we realize that if at the point of cement all this issue that it will disturb us when we are doing coding, so it is more preferable we do some cleaning here so that we should allow only cement here, all this one down we should remove, we should allow only blaze funnel, all this one down, and so on and so forth. So now I have written now a small code. That code now is telling us that what I said df, we have omitted df dot column, right? So now I want now that the column cement blaze funnel. So at the point where I have to put the only cement, the only blaze, so and so on. So at that point it is going to do what? Reduce now all that length of, right? So if I call, I've run it down, I call df run, you realize that this is cement blaze. It is now clean than whatsoever you saw before. Are we there? Look at this is the one before and this is the one after. Okay. Yeah. So in this our data we have what? It is 1000, that's 1030 row and 9 column. This is row, right? 1029. 1029 it is because it started from 0 right up to 1029. So with our computer start numbering from 0. That is why we have 1029. So here the total is 130 row and 9 column. 9 column, this is a column 1, 2, right up to 9. Okay, if we look at the column, it ends at compressive strength. If you count the number of columns, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the issue about machine learning is that you need to understand the inside, you need to understand the concept about what you are doing, understand everything, because if you don't understand what the machine will be giving to you, you'll be unable to interpret it. Okay, yes. Now let's look at now the first 10 of this data. The first 10 now, at this point I don't have too much time for us to be typing because this lesson, I don't want this lesson to be too long like the others. Okay, I don't want the lesson to go ahead. So we have df.head. How the df.head, that is the first 10. When we run add the program, we realize that's the first 5. We run add the program, we realize from 0 right up to 4. If now at this point the f now dot head, now we have now listed what the first 5. Okay, let's say if now we need to do what? Yes, place 10 inside here, then we run. It will be what? That is the first 10. If you place 20, it's going to give you the what? The first 20. Okay. If so, if you haven't understand about this concept very well, you have to go back and watch what the previous lesson on pandas. Okay. Yes, you have to watch pandas before entering into machine learning. You cannot learn machine learning without learning the previous lesson on pandas, and also on and you also have Python. Those previous lessons on Python, they are very important. We move forward now for us to calculate the missing value. So using this our code df dot is null is sum. We wanted to sum all the missing value. So now at this point cement we have zero missing value. Base for all we have the missing value is zero. That means there is no missing value. If there was missing value, you will see none. Okay, but there is no none. So you see all everything is okay. Okay, they will move forward. Okay, now at this point now we have written a new code. This one is a new line that you I have not give it out. So if we need to look at this new line, split the data into training and testing. So in the other set, we just do all the calculation without splitting our data into training. It is the same as you are the math teacher, you teach mathematics in class. So you decided that okay, that when you teach your lectures, when you give your lectures out, the what you have to give in the exam, you decide to teach the student. So if you what you have to give to the exam, you teach the student. The time that you give the exam, they will pass very well because why? The same exam that you give at the period of exam, you have already given in the class, so they have to succeed. But now that is not a good way of teaching your student. You have to teach them, give them various exercises, but what you have to give in the exam, you have to keep it aside. So that they should not really be trained with the same thing, because when now you are being trained with the same thing, with that same knowledge, and they give you the same exercise, if they give that same exercise in the exam, you will still succeed. Yes, if I give you 1 plus 1 equals to 2, I teach you that same reason. Then now, if I need to come and teach you, I have to teach you addition. I can give you 3 plus 4, but not still to give you that 1 plus 1, because that 1 plus 1 is showing that it is like a cramming work. That is why now we decided to split the data into the training and testing set. So there will be in this our data now we'll have now some percentage that will be trained and some percentage that we are going to test them. So now what are those percentage? We are going now to use write X train, X test and Y train, Y test. So they are going to be in X and Y direction. Okay, now that's equals to train the test split of what? The size of 0.2, the test size. So what we are going to test, it will be what? 20%. Okay, we are going to train 80% and we are going to test we are going to test 20%, train 80%, test 20%. So random state, and this random state now 42 is telling us that what? When you run the program, it should remain the same. There should not be any changes. If you don't place the random state, when you run the program, when it gives you a given figure, when you run it the second time, it gives you something different. Okay, we are going to see about that. Okay, so we have run this program. Also, I have written this code in order for you to see the diagram on how I shared the X and the Y label, the X test and the Y. So at this point, look at very well. This is the X and this is the Y. Are we together? So this is a train, this is a test. Okay, now our X start from here, end here. Okay, then our Y start from here, our y is a green. Are we there? And the x is a future and y is a predicted. What we need to predict. Are we together? Then the train set is the one that 80% is a train set. Why now 20% is what the test set. That is why you see the test set is smaller than the train set. Okay, so we have now what? X train, are we there? And we have X test. And we have what? Y train at the train set, and we have Y at the test set. That is the reason that you see at this point we write this code X train, X test, Y train, Y test. Then now we write that is equals to, should be equals to the train test split. We split it now. Okay. Yeah. Thank you. Let's move forward. Yes, at this point now, let us now initialize the train and the linear regression model. Okay. Once you run, this is the model that is doing our calculation. We have to initialize the model equals to linear regression model. Model dot fit. We have to fit now the train set and what the X train and the Y train. Okay, the X train and the Y train. Okay. When we do that, we have to, the next thing we have to predict on the test set. Y predict is equals to what? The model dot predict X test. So we are predicting now the X test. Okay. Why are we predicting X test? We are predicting X test because X test has been kept 20% only for what? For tests. You understand me? You thought for 8% and now you want now to test it out because your exam, you don't need to give too much exam, but you give now exam now just small, but in respect you cover all the topic, everything, okay, that you cover, that you have taught. So that is why we predict on the X test. So this is the X test that we are predicting. And what we have, what? Y predict. So we are predicting the Y value, Y predict because we want the model of fit X test. So when we do that, we evaluate the model. We evaluate the model by using what? The mean square error. Mean square error for Y test and Y predict. Okay. So now we move now to R square. R score the Y test over the Y predict. Then we also then look for what? The coefficient. Model the coefficient. So these are the process. We have run this program. Now we wanted to print the evaluation metrics and the coefficient. We want to print what we have run to see it. Now we are going to see results. Okay. Okay, now this is the result. We have now what? Our intercept. This intercept is minus 28.3192. We have the mean square error is 100 point. This is the error 100 point. Okay. Then we have the R score is 0.66. So when the error is smaller, it's a good news. This error is too much. Okay. We have regression coefficient. Now regression coefficient, we have what? It is 1, 2, 3, 4, 5, 6, 7, 8. Why is it 8? It is because why? In this our data set, we have what? 1, 2, 3, 4, 5, 6, 7, 8. That we use it as our X train and X test, 8 of them. Then we use this one to predict. That is why you have it here. Our regression is a coefficient. Because last time I told you guys that we have what? Our formula y equals to mx plus c, which obviously m stands for the coefficient we have at the point of it. Then now c stands for what? For the intercept. Okay. So now this is what the various coefficient. The various coefficient in each of that point. Cement, Blaze funnel. So these are the various coefficients. So there are 8 because there are 8 that variable that we test on our future. In our future we have 8. Okay, our future there are 8 and our target is 1. Okay. Okay, now I write a code that assuming the model is a train linear regression. Assume the future is equals to the whole of this are our features. I want us to assume that this is our features. We run it. When we run it, then we assume the coefficient is the list of the array model coefficient. We run this one. After doing that, why am I doing this? I wanted to print now this same coefficient, but now the coefficient now with respect to what? There are various variable so that you will understand it well. Okay, print the coefficient. I want to print those coefficients back. So now the coefficient cement is 0.11. Look at it here, 0.11. So cement is 0.11 for a coefficient. Blaze furnace 0.10. Blaze 0.10. So that is fly ash, water. So these are the various coefficients. I am doing this for more explanation for you to understand it very well, because this thing is not difficult. The issue there is you just is a conception in mind, and there is no calculation over this matter. You just need to understand the concept and you move ahead. Okay, there's a formula that I want us to look at the formula. Okay, and for us to look at the formula, we have to run this code. When we run this code, now we are going to have this formula: y equals to b0 plus b1. This is now at this point it's the same as y equals to mx1 plus mx2 plus mx3. Okay, the same as y equals to b0 plus b1x plus b2x. Okay, so this is the intercept b0. Are we there? This is the intercept. Now we have what? So if this is the intercept, this now the point of b is a slope. Are we there? Now at this point we have where y is the predicted value, concrete compressive strength in this case. Then b0 is the intercept. B0 is the intercept. As I said, b0 is the intercept. b1 and b2, b to the n, are the coefficient of the respective features. The coefficient of the respective features, x1, x to the n. How there? So I say, given the intercept and the regression coefficient, the equation of the predicted compressive strength y based on what provided data will be. So at this point, I'm writing, start with the intercept. I'm writing all this code. I wanted to print now the equation of the line. Yes, equation of the line. So now this second code will print the equation of the line. Okay, for the first code, I say start with the intercept equation. F, the function of y is equal to the model intercept, that's in 3 decimal places. Okay, at this point now, add the coefficient for each feature. I say for I coefficient in what? Enumerate the model dot coefficient. Are we there? The coefficient now should be what in 3 decimal places. Multiply the coefficient with the features. I say multiply the coefficient with the features. Then I say print the equation of the line. So here we are going to see the equation of the line. So we print the equation of the line, y equals what? So if you look at this y, are you see is the same thing here? Y equals what? This, I say what? B is the intercept. This plus this multiplied by what? The cement multiply. This is the equation. Okay. Now, intercept replace with the what? The actual intercept if known. Are we there? And the intercept is what? The intercept is equal to minus 34 point. Our intercept, what is our intercept? We have our intercept here. From here, our code, this intercept. So the intercept is minus 28.3. Yeah, is the intercept minus 28.31. Okay, because I wanted us to run this intercept because it's something ahead. So when I run this, predict the compressive strength. Prediction is equal to the intercept plus the sum, the L, the feature times the coefficient. Okay, this is the formula. We are still going ahead. After we run this formula, we have to move again. So when we do this, it's still going to give us the same thing that we have in above. So it still give us the same thing. Why are we doing the repetition? We are doing this in a sense that you should understand about the concept. So the equation of the line of the composite chain is equal to, at this point now we have what the composite chain now, not the line, not y. Okay, we place now at the point of y, we place composite chain equals to this equation. Are we together? So at the point now where there was the cement, when you place what the value of cement, at that point you're going to have the composition. This is cement, right? If you are what on 1, you place cement 540 at the position of cement. Okay, the place funnel you place 0, fly ash you place 0, water you place this. When you place all now, you are going now to have this composite chain 79 point this or something closer. If it is not closer, then now it's showing that what we have to adjust our problem. That means we have a certain problem that we have to adjust. If it is something that we have to adjust, I'm going to let you guys know. We have to run this, then finally we have to run this code, print all the prediction. We have to print the prediction. Okay, need to know. So our prediction now, predicting compressive chain. At this point, we have what from row 1 right up to what go down. We have what the total row was what 1000, right? We have 120 or 130. Are we there? So this is all the prediction. This one now has been done what by the use of what our machine. Okay, but this our prediction is not the best. Let me go up. This prediction is not the best. This is row 1 52 96, and obviously yeah, if you look at our prediction, we expected 79 but the machine give us 52. It is not good, it is bad. So now what can we do in order to solve this problem? I'm asking you a question. What can we do in order to solve this problem? So now in a nutshell, in the next lesson, I'm going to teach you guys on what to do to solve this problem. And we are going to introduce on a topic called one-hot encoding. Okay, one-hot encoding. One-hot encoding is going to help us. That means we are going to code our what various variable. Are we together? When we code our various variable to reduce the size, because if we look at this point, we have what our size. Look at our size 300 and this 0. It is not good, so we have to code this various variable so that it can be either 0 or 1. Are we together? When we code all those, we are going now to solve this problem. Then we are going to compare now the answer with what the previous answer with the past answer. So this answer now with the past answer, while the other one that we are going to use, that one hot encoding, will be the previous answer. Okay. Yes, thank you for your time, and I wish that by the end of this month or next month, we have to go far. Because in daily basis we are working and we are uploading video. So make sure you subscribe in the lesson so that in every day when I upload the video, you're going to be the first person to see it. Okay? Take care. Bye bye. Wish you the best. Yes, don't leave. This is not the time for you to leave. Please help me to subscribe in this my channel. Also, make sure you place the notification bell so that every time that I upload a video, you'll be the first person to watch. Okay? Yes. Okay, thank you also for helping me to share this video. Thank you also for helping me also for watching. Yes, I wish you the best. Thank you. Bye bye.